Hello everyone, welcome back. So today we are going to be talking about two-dimensional shapes. We're going to be modeling the effect on them with linear and area measurements of dilated two-dimensional shapes. So let's begin. The area of the figure below is, the perimeter of the figure below is. So first we're going to start off by finding the area. We know the area equals the base times the height. The base here is 2 and the height here is 2. So 2 times 2 is 4, so the area of the figure is 4. We know that perimeter is found by adding all of the sides. We have 4 sides and each side is 2, so we can multiply 2 by 4 to get 8. So our perimeter is 8. The question says, how would the figure change if we doubled each side length? So let's say instead of being 2, it became 4. Well, the area of the new figure above is 4 times 4, base times height, which is 16. And the perimeter would be 4 times 4, because there's 4 sides, each are 4. So the perimeter would also be 16. So let's look at this a little more. When we're looking at dilation, we can see that our first figure was 2 by 2, and our second figure was 4 by 4. So our scale factor becomes 2. What scale factor is just by how much your figure is increasing or decreasing. Because our scale factor is a whole number, it means it is increasing. So we went from a side of 2 to a side of 4. Originally our perimeter was 8. So you do x times the scale factor, so 8 times 2, which gives us the new perimeter of 16. For area, our original was 4. We did x parentheses 4 squared, so we have 4, which is x, times the scale factor of 4, or times the scale factor of 2 to the power of 2. 2 to the power of 2 is 4. 4 times 4 is 16. So you can use this formula, x times the scale factor, to find perimeter. And then for area, you can use x parentheses scale factor to the power of 2 for the area. So we can use these formulas. So let's go ahead and look at this problem. It says Eric has a square floor tile that has an area of 9 square meters and a perimeter of 12 meters. If he triples all dimensions of the square, what would the new area and perimeter be? So our scale factor is going to be 3. I know this because it says triples, which tells me I'm going to go to a larger number. So I know my scale factor is a whole number. And also a triples is the number 3. So k is going to equal 3. Now we're going to use these formulas that we wrote down here to solve for our perimeter and our area. First we need to do perimeter. This is going to be x times the scale factor. In this scenario, our perimeter is 12. We're multiplying that by the scale factor of 3, which gives us 36. So our new perimeter is 36. We're going to use the area formula, which is x times the scale factor to the power of 2. This is going to be, our area is 9. So we're multiplying that by 3 squared, which gives us 9 times 9, which is 81. So our area is 81. The area for this was 9. We know that the square root of 9 is equal to 3 from our perfect squares lesson. So that means each side is 3. So we have 3, 6, 9, 12 as the perimeter. 3 times 3 is 9 for the area. And then the side lengths of this, it says square root of 81 equals 9. So each side length is 9. 9 plus 9 plus 9 plus 9 is 36, or 9 times 4 is 36. So that is how you find the perimeter and the area. Let's try one more. Jason made 4 square game with his chalk outline. His area of the square was 25 square feet and his perimeter was 20 feet. He wants to reduce his dimensions by a half. What will be his new area and perimeter? So our scale factor is going to be 1/2. It tells me that right here it's reduced, so it's going smaller. Our scale factor is a half, which is less than 1, which tells us that it's going to get smaller. So it's a reduction. So our original area is 25 and our perimeter is 20. Well, let's look. We need to find the perimeter first, and we used x times the scale factor. Our perimeter is 20 times 1/2. Another way to write this is 20 divided by 2, which is 10. So our new perimeter is 10. And then we have x times the scale factor squared. X is 25. The scale factor is 1/2 to the power of 2. 1/2 times 1/2 is 1/4 times 25, which is like saying 25 divided by 4, which is equivalent to 6.125. So our area is 6.125. Or it can go into 25. 6 times, which is 24. Remainder 1. Bring down the 0. 4 can go into 10 2 times. 2 times 4 is 8. Bring down the 2. 4 can go into 20. So 6.25. Sorry. So our area is 6.25. Alright, that is all for today. If you have any further questions, reach out to your teacher through Canvas, and I will see you in the next one.